Hello?
Hello, hi. Can you hear me?
Hi. Yes, I can hear you.
Okay. So, instead of maths, we have to do physics, right?
Yes, yeah.
Okay, and that paper, this paper, forwarded to me like today.
Yeah, but first we need to finish off the Unit 2 paper.
Yes, the previous one, right?
Yes.
Okay. Okay. Can you see the screen?
Yeah.
Okay, so I'm asking this question, like part B. Have you completed
Okay,
this?
part B.
Because I don't think so. We have
Uh,
completed it.
yes, we've
Uh,
done this. We've done it.
okay, we have completed this one.
Yes.
And then it's okay. It's question 4. So you haven't completed this in the school. And this part C also, it's like current voltage graph, which is not completed. And student investigate. Okay, now see this question. This resistor, this also not completed in your school, right? Like
Yeah.
it's connected in parallel and
Mm-hmm. Yeah,
that's still not
I've looked through
completed.
the rest and we haven't done the rest in school, so
All
we'll,
these,
let's,
yes.
yeah.
Like, and this radiation detector space between star galaxy, this one also not completed. Like,
No.
okay. So like we have to move on to the next paper.
Mm-hmm.
Okay, so this is the paper, right?
Mm-hmm.
Okay, now tell me question first.
Okay, let me just get it.
Okay.
Okay. So 1A, a marble is rolled up a smooth slope as shown in the diagram below. From the moment it leaves the person's hand, it takes 4 seconds to come to rest, and in this time it travels a distance of 48 centimeters. So calculate the average velocity over of the marble.
Yes.
Okay. So velocity is distance over time. Wait,
Okay, so
what?
like which question are you waiting?
I'm
Because
on question 1A.
okay, like because the paper that I opened, this one is one kind of earthquake wave. Is this like the
This
paper?
is the
This is the
oh
one
this
that
is
I have received today.
this is the January the 2019 one.
Yes, so that's the paper that I have received today.
Okay. Could you scroll up, please? No, up
Okay,
to the
yes,
starting page.
So it's Friday, 24th June morning. Okay.
Oh, okay. Um, so let me just send you the correct one.
Okay.
And here are the answers.
Okay, this one, right? Thursday, 17th January morning.
Mm-hmm.
Okay, so a marble is rolled up a smooth slope as shown in the diagram below. Okay, this one.
Yeah. So velocity is distance over time.
Yes.
So 48 over 4, which is um, which is 14. So
That's 12. Like 48 divided by 4 is 12.
oh right, yes, sorry, 12. So it's 12 centimeters per second.
Yes.
Okay. Um, During this motion, the marble moves with uniform acceleration. Use your answer to part 1 to calculate the initial velocity of the marble. Uh, okay, so it moves with uniform acceleration, and the initial velocity is the initial velocity is the starting velocity.
Yes.
So v equals u plus b over 2.
Yes. It's u
Okay,
plus v
so
over 2 is a, like directly you can say a acceleration. Using the formula of acceleration you can calculate. That is change in velocity over time. That you can use. Or you can use u plus
okay,
v over 2.
okay. Um, right. So the acceleration equation. So acceleration is um. So acceleration equals u plus b over 2.
Acceleration is equals to v minus u over t. But here acceleration is not given. You can use the formula of average velocity, which is initial
Okay,
plus final divided by 2.
okay. Um, right. So initial velocity is 0, and final velocity is 12 divided by 2. So its initial velocity. Oh wait. Oh no, wait. We don't know the initial velocity, and so we need to
Find out
rearrange
the
the
initial
equation.
velocity.
Okay. Right. So u plus 12 over 2. No.
Wait. It's given as calculate the initial velocity of marble. Show clearly how to get the
Mm-hmm.
answer. Now see, this stone has moved from this point to this point. That means initially it was moving and until ultimately it comes to rest, because you can read the question, from the moment it leaves the person's hand it takes 4 seconds to come to rest. That means
Mm-hmm.
final velocity is 0 because it has come to rest, and initial velocity we have to calculate. Now average velocity is what? Its average velocity is final velocity plus initial velocity divided by 2. Okay, Or I can write
Mm-hmm.
u plus v over t is equals to v average. We have calculated average velocity to be 12. Initial
Mm-hmm.
velocity is u, final is 0 divided by 2. So by cross multiplication, I can calculate 24 equals u. So initial
Okay.
velocity is 24 centimeters per second.
Alright, so 12 times 2 equals u, and so u is 24. Okay.
Now we go to the
Alright.
next one.
Question 3. On the grid below, carefully draw carefully the velocity time graph for the marble during the 4 seconds of its motion. Okay. So velocity per centimeter. Okay. Velocity, which is centimeters per second, and its highest velocity is 12. All right.
You can
Or no, wait.
you first have to plot the initial velocity and the
Mhm.
final velocity.
Okay. The initial velocity was 24, and so I need to find out the final velocity. Okay. So the final velocity was the final velocity was 0.
Yes.
Okay, and the initial velocity was 24.
Yes.
Okay, so the graph needs to go up to 24.
Yes. So you have 2 points. One is 0, 24 and one is 4, 0.
Okay,
These are 2 coordinates. Locate these 2 coordinates and join them together.
okay. So so the coordinates are um,
Okay, you tell me what are the coordinates?
wait uh wait let me let me like put down the velocity first.
Yes.
So Okay, so it goes up to 25, and I need to plot the points. So I need to draw it during the 4 seconds of its motion.
Yes. So final
Okay.
is 24, like its initial is 24.
Mhm.
And
Yeah.
final is?
Um, Final is 0.
Yes. So it goes from 24 to 0.
Okay.
And you have to find the time, like at which time the velocity was 24 and at which time the velocity was 0.
Okay. Right. So, so um, at 0 seconds of its motion, the time was no, the velocity was 24.
Yes, so at time 0, at t equals 0 seconds, the velocity is 24 centimeters per second.
Okay.
The time will be
Um,
0, and if you are plotting here, it's 24 something, right? Then you can take a gap of 10 or 5, like 5,
uh-huh.
10, 15, 20, 25. So here definitely here somewhere 24 you'll get. So it's 24, one coordinate will be
Mm,
here, and second is at time equals 4 second, velocity 0, so it's here. So these are the 2 points,
okay.
and then join
All
them
right.
together.
Okay, done. Okay, I've done that. Now use the graph to calculate the acceleration of the marble.
Yes,
Okay. So acceleration is v minus u over t.
yeah,
Okay. So v is the so v is the final velocity and u is the initial.
yeah,
Okay. So the final velocity was 0 and the initial velocity was 24 and the time was 4 seconds. So minus 24 over 4, which gives us um, minus 6.
okay. So it's,
So, so the acceleration was minus 6 centimeters per second squared.
yes, that's correct.
Okay. On another occasion, a marble of mass 80 grams has an acceleration of minus 0.09 meters per second squared. Calculate the size of the force slowing the marble down. Okay. So F equals ma. So mass times acceleration. So the mass was 80 grams times minus 0.09, and that gives us, let me see. Okay, 80 times minus 24. No, 80 times minus 0.09 is 7.2.
It's, yes, 7.2.
Okay, so the force is 7.2 newtons.
Not newtons, like it's 7.2 into 10 to the power minus 3 because it's 80 grams. So it
Oh,
should be in kilograms. The unit should be in kilograms. So first you have to convert this into kilograms.
okay.
So answer is 7.2, but it's into 10 to the power minus 3 because 1 gram equals 10 to
Okay.
the power minus 3 kilograms.
Okay. Um,
Is this clear or should I
right.
write this one?
Yeah. No, it's clear.
Okay.
So times 10 to the minus 3.
Yes.
Okay. So that's 0.0072.
Yes.
Okay. Um, a force called the centripetal force causes the body to move in a circle. Give an account of the factors that the centripetal force depends on and how it depends on them. The account must state the direction, the three factor affecting the size of the centripetal force, and how the centripetal force depends on each of these factors. Okay, so centripetal force causes it to move in a circle. So the direction is it moves towards the center of a circle.
Okay, so force from centripetal. Here account must state the direction of centripetal force. Okay, so direction of centripetal force is it's given as towards the center. Okay, so it's towards the center. The direction of
Okay.
centripetal force, it's always towards the center. Okay, that's the
Okay.
first thing. Direction is. Now three factors affecting the size of centripetal force.
Okay. Um, three factors. Um, the mass of the body.
Yes.
Um, the the radius of the circle.
Yes, radius is correct. So first you tell me what's the,
And
like, do you know the formula to calculate the centripetal force?
no.
Because if you know the formula, then it's much easier for you to calculate, like the factors dependence. It's mv square over r. That's centripetal
Okay.
force. So you can say, like, what are the factors? First is the mass, second is the velocity,
Mhm.
and third is radius. So these are the three factors on which the centripetal force is dependent.
Okay. So mass times velocity times the velocity squared divided by radius.
Yes.
Okay. So the velocity also affects it. so velocity of movement and how it depends on each factor.
Okay.
Okay. So
How centripetal
um,
force depends on each factor. Like, according to this formula, you have to describe this, how it's dependent on each factor.
um, it, well, the centripetal force will increase when the mass increases.
Yes, that's correct.
Um, so will force will increase when mass increases. Mm, um, well, it'll increase with the speed.
Yes.
Increases when speed increases, and um, it'll decrease as the radius decreases.
Yes. So you can see that centripetal force is directly proportional. Like if you see this formula, this mv squared over r. So clearly you can see that this force is directly proportional to mass. This force is
Mhm.
directly proportional to square of velocity, and force is inversely proportional to r. So in this manner you have to describe the first, directly proportional to mass, directly proportional to square of velocity, and inversely proportional to radius. That means if mass increases, force increases, velocity increases, force increases, and radius increases, force decreases. Okay.
Mhm.
So in this way you have to describe this.
Okay. Right. So the next question, um, number 2A. Electrical energy can be obtained by burning fossil fuels. The simplified diagram below illustrates the energy changes that take place during this process. For every 120 kilojoules of input energy, two-thirds of it are wasted as heat from the furnace. Of the remaining useful energy, 16 kilojoules are lost as heat and sound in the turbine. Um, the, the remainder of the useful heat energy is converted into electrical energy. Complete the diagram below um, by adding the appropriate numbers to the boxes and the type of input energy. Okay, so the input energy from the fossil fuels is chemical energy,
Yes.
and in the furnace, 16 kilojoules are lost as heat.
It's 16 kg are lost as heat and sound in the turbine. So it's in turbine that's given, right? 16 kg
Okay.
are lost as heat and sound in the turbine. Whereas for every 120 kilojoules input energy,
Mm-hmm.
two-thirds of it are wasted as heat from the furnace. So calculate two-thirds of 120. That's the loss energy in furnace.
Okay, so two-thirds of 120 is um, 80.
Yes, so it's 80.
Okay. Um, furnace, it produces, uh, and so you take away 80 from 120,
Yes.
so 12 minus 8 is 4. So it produces 40 kilojoules of useful energy.
Yes.
um, and the turbine generator 16 kilojoules of wasted energy,
Yes.
and um, and so we need to take away 16 from 40.
Yes.
Um, so 24 kilojoules of useful electrical energy. Okay. So number 3. Um, state in full the principle that allowed you to answer part A 1. Um, the principle that allows me to answer. Uh, mm,
Like you tell me, which principle you know related with energy?
Pardon?
Which principle or law do you know related with energy?
Um, uh, he.
A law that you have studied like in energy, in chapter energy. What's the first law or the important law when we study energy, types of energy, or flow of energy, transfer of energy? What's the important law that we study?
Energy cannot be created nor destroyed, but it can change from one form to the other.
Yes, so that's the answer.
Okay.
So you can clearly see
So,
whether it's in furnace or like energy keeps on changing its form, right? It's 120
mhm.
kilojoules, now it's in furnace, it's lost, then it's remaining. So you can see that energy keeps on changing its form, but total energy remains the same.
Okay. So energy cannot be created nor destroyed, but it can change from one form to the other. Okay. Every second, a different fossil fuel power station produces 840 millijoules of megajoules of electrical energy. The efficiency of this power station is 0.35 or 35%. Calculate the amount of fossil fuel energy this power station uses per second. Okay, so mm, so the total energy um, so the total energy input equals the useful energy,
Yes.
take away the um, the waste energy.
Like you have to add them.
Okay. Okay. Oh wait, no, I need to
But
multiply it
also
by
like
the
uh,
efficiency.
like its efficiency, you have to divide it with efficiency, not multiply, divide it with efficiency.
Okay. All
Because
right.
input
So,
energy should always be greater than the
mhm.
used one, right? That's
So
true.
useful energy divided by efficiency. So 840 divided by, or yeah, divided by 0.35. So that is 24, no, 2,400 megajoules.
Yes, that's correct.
Okay, one of the major disadvantages of fossil fuel power stations is that they all produce gases which pollute the atmosphere. State the common polluting gas produced by all fossil fuel power stations. Okay, carbon dioxide.
Yes.
Um, in what way is this gas particularly harmful to the global environment? Um, okay, it causes global warming,
Yes.
like the greenhouse effect.
Yes, so it's a greenhouse gas, basically carbon dioxide, which traps the heat energy, and it doesn't radiate it. That's why it raises the temperature of our atmosphere.
Okay, so causes global warming by trapping
Heat,
heat in the atmosphere
yes,
and
raising the
heat
temperature.
and raising the temperature. Okay. Um, all fossil fuels are non-renewable. Explain what this means. Um, it means that um, it can't be replaced in a human lifetime and will eventually run out.
Yes, that's good.
Can't be replaced in a human lifetime and will eventually run out. Okay. Um, many scientists are investigating the use of water waves to produce electrical energy. In one investigation, the electrical power P was extracted from water waves, um, um, and it was measured when waves of different height h were used. So the power of P is directly proportional to the square of the height h of the height h of the wave. So using this information, circle the correct information from the three um, shown, looking at the power of P, um, the height of the wave h, and the constant proportionality k. Okay, so P is directly proportional to the square of the height h. So P equals kh squared.
Yes, this one's correct.
Okay. The graph below shows the results obtained from the investigation. Using the appropriate equation and the graph, find the value of the constant of proportionality k and state its unit. Okay. Um, okay. So the equation is the equation was P equals kh squared, um, and um, one of the um, one of the values is 2.0. The height was 2.0, and the power was 8.
Yes.
So 8 equals k times 4. And so we take the 4 and put it at the other side, and it becomes 8 divided by 4 equals k,
Yes.
and k is 2,
Yes.
and the and the value and the unit for k is
Like unit is like you have to make k the subject. So then k is equals
okay.
to p divided by h squared, and the unit of power is watts, or it's in kilowatts, and h squared is the height, so it's in meters squared. So this is kilowatt per meter squared is the unit. Is this clear?
Okay. Yes. Kilowatt per meter squared. Okay. So next question. 3A. When studying the principle of conservation of energy, a student carried out an investigation by allowing a small ball bearings to run from rest down a curved plastic track as shown in the diagram below. You can assume the force of friction is negligible and thus no energy losses. Mm, Each ball bearing has a mass of 0.02 kilograms, and
Yeah.
the ball bearing is released from the point A, which is 1.8 meters vertically above the horizontal as shown in the diagram.
Yes.
So calculate the loss in gravitational potential energy as the ball bearing moves from A to B. Okay. Um, so gravitational potential energy. So E equals mgh.
Yes.
Uh, so mass. So mass is 0.02. Wait, is mass in grams or in kilograms?
Mass should be in kilograms. So it's already given in kilograms.
Okay. Um, okay. So G is um,
Like either you can take it as
G.
9.8 or you can take 10.
Huh. Okay, 10. And the height was 1.8 meters. Okay. So 0.2 times 10 times 1.8, which gives us 0.36 joules.
Yes.
Okay. Kinetic energy of the ball bearing at point B. So kinetic energy is um, kinetic energy is equal to the gravitational potential energy.
Yes. So it's
Okay.
0.36 joules.
So 0.36. Okay. Number 3, calculate the speed of the ball bearing at point B. So speed is dis so speed is distance over time. So mm, so so we need to use the like formula for the kinetic energy,
Yes.
which is a half mv squared.
Yes.
Okay. So Ke equals a half mv squared. So, m is 0.02 kilograms.
Yes. 0.02.
The okay, the speed was okay. So the speed we don't know. So kinetic energy was 0.36.
Yes.
So 0.36 equals a half times 0.02 times v squared. And v squared is 0.36 divided by 0.01.
Yes.
So v squared was 36 and v is 6. So speed at v was 6 meters per second.
Yes.
Okay. When the ball bearing reaches the point B, it travels along a horizontal track where friction does act. The ball bearing travels 0.9 meters from point B before coming to rest at C. Calculate the frictional force acting on the ball bearing. Right. Um, so we need to do the we need to work out the frictional force. So to do that, we we do work done.
Yes.
Okay, so work done equals initial. So it work done equals kinetic energy times the distance.
It's actually force into distance.
Oh, okay.
Like
Force
work
into
done is energy. Basically, energy is work done is energy transferred. How much energy has transferred, that's basically work done. Okay,
Mm-hmm.
so that's why energy and work done both has same units, that is joules. So work done is
Okay.
equals to force times distance.
Okay. So 0.36 times 0.9.
Yes, like it's force, it's not given, right? Force, you have to calculate the force.
Okay.
So it's F into distance. So distance is given as zero point 0.9 and
Mm-hmm.
energy is 0.36. So it's force multiplied by zero point 0.9 is equals to 0.36.
Okay. So 0.36 equals F times 0.9. 0.36 divided by 0.9 is so 0.36 divided by 0.9 equals 0.4.
Yes,
So the frictional force is zero point 0.4 newtons.
yes, that's correct.
Okay. Um, Number 2. If the track between A and B was made steeper, how would this affect, if at all, the distance to the ball bearing towards B? But ball bearing travels. How would this affect at all the distance the ball bearing travels from B towards C? Explain your answer. Okay, from B towards C. So a steeper track Um, so a steeper track between A and B would would increase the speed.
Yes,
Um, um, so, so the distance the ball bearing travels.
okay, so explain. It's basically, it's given if the track between A and B was made steeper, how would this affect? If at all the distance the bearing travels from B towards C. Okay, from B towards C. Explain your answer.
Okay, so the
If at all
distance
the distance,
between
like that's more important. If at all the distance the ball bearing travels from B towards C, from this point to this point.
okay, so the distance between B and C still remains the same.
Yes, like here, whether it's energy or velocity whatsoever, it's not going to change.
Okay, so no change. The distance between B and C remains the same. Okay. C. In a school laboratory, small trolleys are often used to investigate momentum. The diagram below represents what happens when two trolleys collide. After
Okay.
the collision, the trolleys stick together. Using the principle of conservation of momentum, calculate the velocity of the combined trolleys after they collide.
Okay. So, like principle of conservation of momentum is that the momentum,
Mhm.
initial momentum should always be equals to final momentum. That means momentum before collision is equals to momentum after collision. Okay. So that's the principle of
Okay.
conservation of momentum. And also like it's I have my next class, so I can continue this one. This we will continue in the next class. That's tomorrow, right?
Yes.
Okay, so try to solve this question, and if you can, then we will continue in the next lecture. Okay?
Okay.
Okay then.
Thank you.
Thank you. Bye.
Bye. Bye.